We want to dance, dance, la 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 la, ooh. And I'll spin and dance and I'll even break it down. Wiki, wiki. Oh. Look at this new set. We finally made it big time. Ah, yes, I love it, don't you?
Divide, add or subtract, figure what the answer will be. You can do it with a little help from your friends here on TV. Math homework helpers, it's time, time. Math homework helpers, oh yeah. Math homework helpers, it's time, time. Math homework helpers, oh yeah.
Adam, do I have to ask what you were doing?
What? I'm practicing my beatboxing, of course.
How long have you been practicing, and how long do you plan to continue practicing?
I've been practicing for about a week or so, and I plan on practicing for many weeks to come.
Adam, do you think you could stop practicing long enough to do the show today? You want to do the show today?
Yeah, but you know what, Miss Magnuson? Beatboxing is the show today. Come on, guys.
What about helping kids with their math skills?
Can we do both?
Okay, I guess we could try that.
Sweet! Awesome! Welcome, everybody, to another spectacularly awesome beatboxing math homework helpers. This, of course, is Miss Magnuson from Windsorville Middle School and Miss Frist from Pine Grove Elementary, and me, the incredible beatboxing Adam.
Hey, Mr. Beatbox, aren't you going to introduce our guest spinner today?
Huh? What?
Our guest spinner?
Oh, yeah! Hey, guys, the prize wheel is ready to go, and our guest spinner today is Trey from Glendon Elementary School. How you doing, Trey? Good to have you here. He's ready to spin some prizes today, of course.
We're here to help BCPS students with their math homework. So if you need some help with your math homework, go ahead and give us a call. The number is 410-494-1459. That's 410-494-1459. Once again, 410-494-1459. Then, after we work on your math homework, you get to spin the prize wheel. Who's going to be the very first math homework helper today?
Yes! Who is our first beatboxing kid? Hey, Sebastian, are you there? From Pine Grove.
Hi, Sebastian.
Hi.
Hey, you want to do a little beatboxing with me?
Yeah, sure.
All right, go.
Let us hear what you have. Come
I don't hear you.
Don't
Come on,
be shy.
Sebastian.
Good job.
Nice. All right, so let's get back to some math. What are you working on? I guess Miss Frist would know, huh?
Proportion.
Okay, Sebastian, what problem do you want to do?
Number 5. Last year, a girls' soccer team won 4 games and lost 6 games. This year, the team won 5 games and lost 7 games. Did the ratios of wins to losses vary proportionately? Explain your answer.
Okay, so we have to check the proportion, Sebastian? Okay, so why don't you tell me about those first 2 terms, the wins and the losses?
One team got 4 last year. The team won 4 games and 6 games.
Okay, so they won 4 and lost 6. Okay. Then what happened in the next year?
They won 5 games and lost 7 games.
Okay, so the first proportion or the ratio you're going to set up is 4 to 6, right? What would the next one be?
5-7.
5 to 7. Okay, so the question is, are these proportionate or equal or not?
What do you think?
Not.
Okay. Can you tell us how you
Yeah,
did
how
that?
do you know, Sebastian?
Because 6 times 5 equals 30, and 4 times 7 equals 28, and 28 is less than 30.
Okay, so you're saying these are not a proportion. Okay, and what method do you call that when you multiply like that? Do you remember?
Cross multiplying.
Cross product, right?
Mm-hmm.
So now you just proved. So if you write your
That looks
answer
like
out,
an atom now.
good job. 4 times 7 is 28, and that's less than 6 times 5, which is 30. Then you just showed your explanation. Sebastian, you did a great job. I like that
Wow,
problem.
That's like proportionate. How do you say that?
Proportionate, proportional,
Proportional fractions?
mm-hmm.
Wow.
Equal ratios.
Equal ratios. Sounds like something we could beatbox to.
Well, give
Sounds
it a
good.
try.
Why don't you, Miss Magginson? All right, well, you know
Gee,
what,
Adam.
Sebastian? Why don't we have Trey, who's been standing over there waiting to spin the wheel for you, spin the wheel, and he's anxious to give out some prizes. All right, so Trey. Oh, yeah, he is ready to give out some of my stuff. There's the spin. There's the spin. Sunglasses!
Yeah.
Oh, I wish I had
have
a pair
any.
here. I don't have a pair with me today. Where did I put that?
That would
Just
be great
in time for the
beatboxing.
sun.
I know, it's a beautiful. Is it sunny out there today?
No, but it will be tomorrow and next week.
Really?
Yes.
Oh, awesome.
Okay.
Because in this virtual world, we live in a windowless environment. No
Oh.
window to the outside world.
Oh.
Anyway, let's not be sad about that. Let's go to the next caller. Chahat, are you there?
Yeah.
All right, Chahat, ready? Let's do a little beatboxing. Give me a little beat. Go. Oh.
Good.
Oh, yeah, you hear that?
I hear him.
Oh, yeah. Chahat and I should go on the road.
All right.
Anyway, Chahat, so what are you working on over there at Norwood these days?
Decimals.
Decimals. Cool. What's your problem? And the talented Miss Magginson will
9
attempt.
and 2/10 minus 2 and 7/10.
Did you get that? I didn't quite hear him.
9 and 2/10 minus 7 and 2/10. 9 and 2/10.
Minus 2 and 7/10.
2 and 7/10. Okay. I wrote it right, didn't say it right. Sorry about that. So does this look like your problem?
Yes.
All right. Well, when we subtract decimals, what's the first thing that we need to do? Do you know the first rule?
No.
All right. The first rule is to line up our decimals. Are our decimals one underneath of the other?
Yes.
Okay.
You always do that with subtraction?
Always. Subtraction and addition.
Okay.
And if I had any empty spaces, I would fill them with, do you know what number I fill empty spaces with?
Bananas?
Not quite.
0.
What do I
Yeah, 0.
fill
0.
empty spaces with? Oh, he said 0?
He did.
Okay, 0. Good job, good job. Well, we don't have any, so we're going to go ahead and proceed with subtraction just like we normally would. What's 2 minus 7? Can I take 7 from 2?
No.
What do I have to do?
Take a 10 from the tens place.
Nice job. So I'm going to borrow 10 from the tens place, and then what am I left with?
8.
And what
so
do I
you
do?
just subtract business as usual.
Yep, same way. And what do I do with the one that I borrowed?
You put it with the 2.
All right, so
subtract.
there you go. So now, I don't have 2. What number do I have?
12.
Can I take 7 from 12?
Yes.
All right, what's that?
5.
Okay, and now I have 8 minus 2. What's 8 minus 2?
6.
There you go. Do you know what you do with the decimal once you're done?
You put it in the middle.
You put it in the middle. You bring it straight down where it was, and because we couldn't take 7 from 12. So I have, what's my answer? Can you read the answer?
6 and 5/10.
Wow.
6 and 5/10.
Great.
Great job. And you understand why we borrowed the 7 from the 12, correct?
And I see why it's so important to make sure you line those decimals up.
That's right.
Chahat probably knew that. So, hey, you know what? Now it's time to... What are you laughing at?
Because it's time
Let's
to...
spin the wheel! Come on, Trey. Go for it! Oh, yes, a flashlight! I love those flashlights. You know, I personally chose them myself out of a catalog of 1,000 pages of flashlights.
And you did a great job.
Why, thank you. All right, you know what? Since we're doing such a good job, why don't we move on to Dami? Are you there? Dami,
Yes.
could you turn your television down, Dami?
Okay.
Yeah, just talk to us over the phone.
Okay.
Ah, beautiful. All right, Dami, you ready to do a little beatboxing with me? Come on, give me a beat.
Okay.
I didn't hear anything.
I actually don't know.
Okay. Well, let's go right to the math then.
Oh.
Okay. It's
Demi.
5 plus. It's 5. Okay. It's a mixed number. It's 5 whole and 2 6
Okay.
plus 4 and 2 6.
Okay. So it's 5 and 2 6, a mixed number, plus 4 and 2 6. Is that correct, Demi?
Yes.
Okay. So we're going to be adding to get the sum of this mixed number. Do you know what you want to do first?
You add the mixed numbers.
Okay. Which part? Do you think we should do the fraction first or the whole numbers first?
The whole number.
Okay. Well, actually, if we do the whole number on this side, Demi, 2 6 and 2 6, sometimes we might get ourselves another whole number. So it might be a little bit better if you use your fraction part first, because then you might get another whole. So let's try that first. Why don't you tell me what 2 6 and 2 6 equals?
4 6.
That's right. Well, in this case, we didn't. But just in case we did, we might want to add that fraction part first. Okay. And then what's 5 whole and 4 whole?
9.
9. Now, how would you say this answer? And then we're going to talk about if we can simplify that. How would you say that one? 9?
9 and 4 6.
Excellent. Did your teacher teach you how to simplify 4 6?
Yes.
Okay. So what do you do to simplify?
First, you have to write down 4 and First, you have to write down the multiples of 4 and 6.
Okay. And I think you mean the factors of 4 and 6, right?
Yeah, the factors.
Okay. So if you have 4 over here, what times what makes 4?
1,
1,
2,
2, and one more,
and 4.
and 4. Okay. And then what times what makes 6?
1,
1.
2,
Good job.
and 3 and 6.
You are great with your factors. Now, what's the greatest one that those two have in common?
2.
That's right. So if we know that 2 is the greatest common factor, what do we do with that 2 over here with our 4 and our 6?
We divide it.
That's right. And we're always allowed to divide by 2 over 2, because do you know what 2 over 2 really equals?
A whole.
It does. And I'm going to draw you a quick picture of what one whole looks like. Okay, so now, what's 4 divided by 2?
2,
2. And what's 6 divided by 2?
3,
3. And our brand new answer is 9 and what?
2/3.
Outstanding. Demi, you did a great job with that. Congratulations. Fractions are hard. You did a wonderful job.
Demi did a great job. All right, and we will reward with a spin of the wheel. Ready, Trey? Trey's gonna crank it up. There he goes. There he goes. And a magic math kit. Fabulous. This magic math kit will allow you never to get another wrong answer ever again. How about that? You believe that one? I'll tell you another one. All right, you know what? You know what? Let's go talk to Blessing. Blessing, are you there?
Yeah, I'm here.
It's funny. I just called Blessing's house, not maybe 20 minutes ago. Did you know that? Because I was calling to arrange that she comes in and spins the wheel next week. But the phone was busy. So I'll call you back a little bit later, okay, Blessing?
Okay.
We'll get you on here. We know you're coming next week.
Yep.
So, what are you working on? We can do your word problem together.
Okay. I'm doing adding and subtracting fractions and mixed numbers.
Okay.
But right now, I'm gonna add the fractions instead.
Okay.
So it says the recipe called for 5/8 cups of sugar and 2/3 cups of flour. How much sugar and flour in all did the recipe call for?
Okay. 5/8.
I know that I'm going to be adding
Okay.
5/8 and 2/3. So I know that I'm going to circle the denominators and 8 and 3, and then I have to list the multiples
Why you
Okay.
doing that?
and 3.
All right. So,
Okay,
go ahead.
so the multiples for 8 is 8, 16, 24. And for 3 is 3, 6, 9, 12, 15, 18, 21, 24.
Okay.
Now, Blessing, are you doing this because the denominators are different?
Yeah, I'm doing it because they're different. Okay,
Thought
so they both have 24 in common.
Okay.
So I had to make 5/8 and 2/3. The denominators had to be out of 24. So
Oh, she's good at
I'm
this.
going to have to multiply 8 times 3 to get 24.
Okay.
And what you do to the bottom, you have to do to the top. So 5 times 3 equals 15. So it's 15 24ths. And for 2/3, I had to multiply 3 times 8 to get 24.
Okay.
And then 2 times 8 is 16.
Now what do you do?
So I had to add 15 plus 16 to
Okay.
get 31
Yes.
over 24. Denominator stays the same. And 31 24ths is an improper fraction.
Good job.
So I had to make it a mixed number.
All right.
Okay. And
we're finished with
24 goes into 31 one time.
All right. So I'm going to catch up with you. And you said 24 goes
Yes.
into 31. How many times?
One time.
Okay.
And leftover is 7
All right.
over 24.
Good job.
Uh-huh.
Okay, so it's going to be 1 and 7 24ths, right?
And what does that represent? What does the 1 and 7/24 represent?
A mixed number.
Okay, it's a mixed number, but it's a word problem. So let's go back and put this answer in the context of the problem.
So how much sugar and flour did? Okay, so it's 1 and 7/24 cups
That's right. Of.
sugar and flour.
Very good. Nice job, Blessing.
Thank you.
You know what? I'm thinking when Blessing comes in next week, we'll just have her be one of the math teachers.
I think so.
She
She's
did such a
ready.
Good job with that.
She did.
Wow. Well, I'll tell you what, Blessing. I know that we can spin the wheel for you. That's for sure. Trey, where are you, buddy? Time to spin the wheel. Here he goes. He's cranking it. What's he got? What's he got? What's he got? Oh, some more sunglasses. Nice. You will look so cool on the beach this summer with those sunglasses. I know because I looked at myself with the sunglasses and I was cool.
You were cool.
Well, I'm cool no matter where I go or what I do.
Okay,
Yeah.
thank you.
All right. Hey,
All
thanks,
right.
Blessing. We'll see you next week.
Okay.
All right. Hey, you know
Hey,
what?
bye.
Why don't we go out to one of the middle schools, Franklin Middle School to be exact. Got a buddy Eric over there. Eric, are you there?
Hi.
How you doing, Eric?
Good.
Fantastic. So you're working on a little algebra, right? Oh, there goes the beatbox.
Oh, he's
beatbox.
Do that again. Oh, he's going to
He's
join
gonna
the
teach
band.
us.
He is
He's
joining
gonna
the
teach us.
band. Nice work on a Beatbox Wednesday. All right, so what do you got for us? The team is ready.
Some algebra.
Some
All right.
algebra.
All right.
Okay,
What's your
Eric,
problem?
what's your problem?
-3 plus y
Negative
equal
3.
to 11.
Is equal to 11. Okay.
That looks like algebra,
Let
doesn't
me
it?
see if I wrote it correctly. -3 plus y equals 11.
Yes.
Okay. So Eric, what do we have to do here?
So you gotta think how to find y alone on that side.
That's right. We have to isolate the variable, right? Okay, now on this side of the equation where you have -3 plus y equals 11, What do we have to do so that
You got to do the inverse, so you have to subtract.
Awesome. Okay, so you have to do the inverse, right?
Right.
Okay, so if we don't have 3 or negative 3, then I don't know if we want to subtract though. What's the opposite of taking 3 away or not having 3?
Like adding 3.
Yeah, like adding 3, right? So you want to add 3. Where do you want to add 3?
Right below it, like it's
Okay.
negative 3 plus 3.
Okay, so do you want to put the plus 3 right here? Underneath, is that okay?
Yes.
Okay, now if you do that to one side of the equation, Eric, what do you have to do to the other side?
You got to add it.
Awesome. So if you don't have 3 and then you add 3, that's just our y, right?
Right.
All alone. So that was your first job. You got y all by itself. Now 11 plus 3, what does that equal?
11 plus 3. That's a hard one.
Okay,
It's 14.
it's 14. So Eric,
I think he was just playing with
I
you.
think so too. You did a great job. Now can I ask you this though? How can you check to make sure that 14 is the right answer?
You do the opposite of what I did.
Okay, so if we put it back in here and do the opposite, if we have negative 3 plus 14, does that equal 11?
Yep.
It absolutely does. Eric, good job.
Hey, that algebra was kind of fun.
Yeah,
It
he did a
was.
wonderful job.
The kid can beatbox and do a little algebra. Well, he deserves a spin. Eric, we're going to spin the wheel, and Trey is ready to roll.
Okay.
All right, Trey, crank it up for Eric. Out there hanging out in Franklinville. There he goes, there he goes, there he goes. Oh, a magic math kit.
Ah, another magic math kit.
And with this, Eric, you will never get another wrong answer. I guarantee it. Or your money back.
Oh, money back. Yeah, about $20.
Yeah, at least. All right, thanks for calling. Call me next week. And you
right.
know what? Why don't we go to another middle school while we're at it? And
think
go to
so.
Old Court Middle School and talk to Tony. Tony, are you there?
Yes.
Let's hear a little of your beatboxing, Tony. Oh, yeah. Oh, yeah.
Nice.
Good too.
See, kids love to beatbox. It's a natural phenomenon. So you're working on these things called perimeters. Is that what I'm hearing?
Yes.
All right. So how is your problem set up, and how can we help solve it for the betterment of all mankind?
It says find the perimeter of a triangle whose side measures 6 3/8 centimeters, fourth 11 over 16 centimeters, and 5 3/4 centimeters.
Okay, can you take a look at my triangle and see if I labeled it correctly?
Yes.
All right, all the numbers right?
Yes.
Okay, so what do we know about perimeter to begin with?
Are you supposed to add
All right, we're supposed to add. And what are we adding in this case?
the bottom number and wait.
Can I break it down to a real simple
length
term?
and the width?
What does perimeter mean? What am I trying to find
Yes,
anyway?
what is the perimeter? Good question there, Adam.
Is that like the area?
Nope.
No.
What's perimeter?
What's to add all the sides together?
Okay. Kinda, Adam, when I talk about perimeter and area, the way I make sure students understand the difference is, let's say you have a puppy.
A puppy? I love
And-
puppies.
All right, so the puppy goes out into the backyard.
Yeah?
The puppy has all the space to roam around and poop and have fun and play.
Okay, all right.
So that's the area, that's his area. But do you want your puppy to get lost?
No.
No, so the perimeter is the fence that keeps him inside.
Oh, yeah.
So the perimeter is around and the area is all of his play space.
Okay, so the perimeter is completely like around.
So it's going to be all around the
like
triangle.
the rim of something. Like
Exactly.
perimeter.
Exactly.
Okay, carry on. I got it.
So, Tony, now that we've helped Adam out, we know that the perimeter is all the way around our triangle. And we need to add all the sides together. Do you agree?
Yes.
So now not only are we doing perimeter, but what kind of numbers do you have here that you're working with?
Fractions and whole numbers.
All right, what do we call a whole number with a fraction? It has its own unique name.
Improper fractions.
Not quite. They're two things mixed together.
Oh, mixed numbers.
Mixed numbers. So you're doing perimeter as well as adding mixed numbers. So we're going to write our numbers. We have 6 3/8 and 4 11/16 and 5 3/4. And we're adding all of these together. Now, what can you tell me about adding fractions?
You're supposed to simplify so they all can have the same denominator.
Oh, we just did
Exactly. We sure did. We need a common denominator for each one of these fractions. Are we going to do anything different to the whole number, Tony?
No.
No, we're going to keep that. So I'm going to keep my whole numbers. But what do you notice with 8, 16, and 4?
Oh, they have the common 16.
16. So what's my common denominator going to be for each one?
16.
All right, nice job so far.
How did he recognize that so quickly?
Well, Tony, how did you know that 16 was my common was going to be my common denominator?
Because 8 times 2 is 16, and 4 times 4 is 16.
And what's 16 times 1?
16.
All right, so
cool.
that's how we got our common denominator. So you already told me 8 times 2 is 16. What do I have to do with the 2?
You have to add the 2.
Add or?
Subtract.
No, I'm going to multiply. You just told me over here 8 times 2. So if I multiply down by the bottom, the denominator times 2, what do I do to the numerator?
You add.
I'm still multiplying. We have to do the same thing, okay?
Yes.
Whatever I do to the bottom, I have to do to the top. So what's 3 times 2?
6.
That's my new numerator. Do I have to multiply 16 by anything?
No.
So what's going to be my numerator?
Is 11.
All right. And what number did you tell me times 4 to get 16?
3. Wait.
4 times what number equals 16?
4.
All right. And whatever I do to the bottom?
Got to do to the top.
So 3 times 4?
3 times 4.
12.
12.
All right. Nice job. Do I have the same denominator for each one of my fractions?
Yes.
So now what do you think we can do?
Add them all together.
We can add them all together. So let's do that. What's 6 plus 11?
6 plus 11 is 17.
All right. And now I need to add the 12. What's 17 plus 12?
29.
Nice job. So I have 29 as my numerator. What's my denominator?
16.
Okay. Now what do I need to do?
Add the whole numbers.
All right, I'm going to add the whole numbers. I'm just going to get some space over here. This is what we've already done. And when I do that, what's 6 plus 4?
11.
And are you sure about that? Let's double check that.
Wait.
6.
10.
And what's 10 plus 5?
15.
All right, so I have 15 and 29 sixteenths. Do you like our answer the way it is?
No.
What don't you like about it?
How the numerator is bigger than the denominator.
Exactly. You mentioned that type of fraction earlier. What do we call that?
Improper.
So how do I fix it?
You multiply the denominator times the numerator. I mean, the whole number, and add the numerator.
Oh, okay. So you want to turn that into a totally improper fraction, but I don't think that's the route you really need to take for this problem. We're only focused on this part of it. So we're going to turn this into a mixed number, and we're going to divide. We're going to divide the bottom into the top. And how many times does 16 go into 29?
It goes in 1 time.
1 time. And can you tell me what I have left over?
You have
9 minus 6?
3.
Okay. And what's 2 minus 1?
1.
All right. So I have 1 and 13 sixteenths. But remember, what else did I have in my answer?
A whole number.
A whole number. What was the whole number?
15.
Okay, so what do you think we're going to do with the 15 and this new fraction that we have left over here?
Add them.
All right, let's do that. What's 15 plus 1?
16.
And what do I do with that fraction?
You add it.
All right, so I'm just going to bring it down. What's my answer to the perimeter of the triangle, Tony?
16 and 13 over 16.
I know that was a lot of work. One more question for you. 13 over 16, does that reduce? Is that simplified?
No.
Can I simplify 13 over 16?
Yes.
You probably think so because you see the 3 and a 6. But is there a number that goes into 13 and 16?
No.
No, it's not. So that's our answer, Tony.
Okay, thank you.
You're very welcome.
Wow. So that's how you figure out the perimeter of a triangle. Especially, wow, okay. So, because we did that, I think that we should spin the wheel for Tony.
I think
Don't
so.
you think so? He deserves a spectacular prize spun by Trey. Don't you think?
I think so.
Plus, he can beatbox.
Yes, he can.
Tony, can I hear a little beatboxing while before we spin the wheel again? All right.
Nice job, Tony.
All right, here we go. Here we go. There he is. Come on, Trey. Thumbs up. And a desk stuffer. And of course, a desk stuffer is all the stuff you want to stuff into your desk. Extra pencils, socks, a pizza, that kind of stuff.
A pizza.
We'll send that right out to you, Tony. Thanks for
Okay.
calling. It's always a pleasure to talk to the talented students of Baltimore County Public Schools. So why don't we keep this trend going and talk to Jay from Newtown. Jay, are you there?
Yeah,
How's it going, Jay?
good.
Good. So, can you do a little beatboxing for me? That was wonderful. What's your problem today, Jay? I understand you're working on fractions. Is that true?
Yeah.
Okay, what's your problem? And we can work on it together.
7/10 plus 5/10.
7/10 plus 5/10?
Uh-huh.
Okay.
7/10 plus 5/10. Oh, look at those denominators.
All right. Yeah, take a look at those denominators. Are they the same or are they different?
They're the same.
Yeah, and that's good for us, isn't it? If we have tenths and tenths, we can add them together. So let's concentrate then on our numerators, our 7 and our 5. Can you add them together?
Yeah.
Okay, what's 7 plus 5?
12,
12. And then what's our denominator going to be? We have 12 what?
10.
We have 12 tenths. Okay, now that answer, do you notice something about that answer?
It can be simplified.
Okay, how can we rename that so we don't have, this is an improper fraction, do you agree?
Yeah.
Okay, we don't want that greater number on the top than in the bottom. So what can we do to make that a mixed number?
Okay. See how many times 10 can go into 12?
That's right. How many times can 10 go into 12?
Once,
It can go once. How many do you have left over?
2,
2. And that's going to be what of your next fraction? On the top or on the bottom?
numerator,
The numerator. Good vocabulary. What's your denominator going to be?
10,
10. So can you read me your answer?
2 tenths.
Good. 1 and 2 tenths as a mixed number. Right, Jay?
Yeah.
Yeah, great job.
So
with
we're
your
done, right?
fractions.
Are we done?
We're not done yet. Jay, are we done?
Are we done?
No.
Is
Uh-oh.
that one of your answer choices, Jay?
No.
No.
Okay, do you know why?
It's not simplified.
Okay, can you help me simplify it?
You can divide 2 tenths by 2 and end up with 1 and 1/5.
You can. You can divide the numerator and the denominator by 2. They're both those even numbers, so you're right. We're going to end up with 1 and 1/5. Simplified. Way to go, Jay.
That was poetry in motion.
That was.
The two of you worked wonderfully, like a
Together.
ballet, like choreographed. All right. Anyway, you know what, Jay? Trey will spin the wheel for Jay. Okay, Trey? Trey, Jay, Trey. I just introduced you. Come on, Trey. Here we go. Here we go. Here we go. A backpack for the J-Meister. We will send that right out to you. All right. You know what? I was thinking maybe we go to OREMS and talk to one of our younger viewers from kindergarten. Ethan, are you there?
Yes,
How are you, Ethan?
Good.
How was kindergarten today?
Good.
Did you have any cookies and milk?
No.
What'd you have for snack? What's
I don't know.
Well, what are you doing in math? Can we work on your math problem?
3 plus 2.
3 plus 2.
3 plus 2. Okay.
3 cookies plus 2 cookies.
All right.
Can you tell I'm hungry?
That's a good one. Okay, Ethan, can you help me? If you have 3 cookies,
Could you make them chocolate chip?
I can make
We
them
sure
chocolate
can.
chip. There you go.
Thank you.
And then you're allowed to go back for seconds and get 2 more cookies. How many cookies will you have all together?
5.
That's right. And we can, you know what? We can even double check them by counting them. 1, you want to count with me? 1, count with me. 2, 3, 4, and 5. Were those cookies good, Ethan?
Yeah.
Yeah, they were good. Great job with your addition.
Ethan, that was wonderful. We could share those cookies, okay? How
think-
about I
yeah.
get 4 of them
And I get
and
the
you
last
get
one.
1?
Well, what does Ethan get?
He gets 1.
Oh,
I get 4 because I'm the star.
But Miss Frisk
he's
wanted a
the
cookie.
star. He
You want a
gets
cookie?
4.
All
He's
right.
the star. He gets 4.
You get a cookie. You get a cookie. You get a cookie. I get a cookie, and Ethan gets a cookie. That leaves us 1 extra cookie, and I'll take it.
Okay.
How about Trey gets it?
We'll give it to Trey. Time to spin the wheel, though, by the way. Come on, Trey. Ethan wants a prize. Oh, sunglasses.
Oh, those
The kids
sunglasses are
gonna
hot
look,
today.
Yeah, they're going to look good at the beach. I can just see Ethan laying out on the beach, reading his novel. All right. You know what? Why don't we go back out to Newtown and talk to Zoe? Are you there? Zoe.
Yes.
How are you, Zoe?
Good.
How was 2nd grade today?
Great.
Did you eat any cookies?
No.
They don't eat cookies anymore, do they? They're busy learning math. So, what math problem do you want us to do?
There are 16 marbles in the bag.
Marbles.
You pick marbles out of the bag. It is blank that you will pick a white marble. And the options are impossible, possible, or certain.
Okay.
16.
How many marbles are in the bag?
16.
15 or 16?
16.
Okay. And do you know what kind of marbles are in the bag?
8 white and 8 black.
Okay. 8 white and 8 black. And your question is again?
The question is it impossible, possible, or certain that you'll pick a white marble?
Okay. Well, impossible, possible, or certain. What does impossible mean?
That it will never happen.
Okay. Well, do I have any white marbles in the bag?
Yes.
So could I probably pick one out at some point?
Yes.
Okay. What does certain mean?
That it has a good chance of getting it.
What if I said another word for certain was definitely? What does definitely mean?
That it will happen.
That it will happen. Are you guaranteed that every marble you pick out is going to be white?
White or black?
White or black. That means that it could be white or black. So is it gonna get, am I guaranteed to get a white marble every time?
No.
No. So we've eliminated impossible and we've eliminated certain. Which one is left?
Possible.
Possible. Are you okay with that answer?
Yes.
And why is it possible? What are my choices?
White or black?
All right, there you go, Zoe.
Speaking of marbles, I've lost mine years ago. And they happen to be 8 black ones and 8 white ones.
Wow, I
Maybe
think she
Zoe's
has
got
them.
them. So Zoe, you know what? We're going to spin the wheel for you.
Yay.
Well, I'm not going to, but Trey's going to. He's been doing a fabulous job. I see a future in wheel spinning with Trey. Here we go. Another backpack.
Ah.
We're handing these backpacks out. We're handing sunglasses out. We're giving out prizes.
Okay,
And
thank
see you.
you.
Thanks for calling,
Thank
Zoe. Let's talk to Gabriella, a 5th grader over at Red House Run. Hey, Gabriella, you there?
Yes,
How you doing?
good.
Hey, we're going to have 2 of your classmates on next week. You know that?
Yeah,
2 of them. So you're going to have to call in and say hello.
yeah.
So, what you want to work on something called GC factors, right?
Yes,
What does GC stand for?
greatest common factor.
Good
Oh, I thought it
job,
was great
Gabriella.
camaraderie. Greatest common factor. What is that?
It lists both. Lists both of the factors for those numbers.
Okay, well, what's your problem? We can do that.
9, 20, 9, 21. 9 out of 21.
Okay. So is it written as a fraction, Gabriella?
Yes,
Okay. So 9's my numerator and 21's my denominator. Okay.
yes.
And you're trying to find what?
The GCF.
Okay. So you want to find the GCF of 9 and 21. Okay. How are we going to start this?
We have to list out the factors of 9 and the factors of 21.
Okay. So let's list all of our factors then. What are the factors of 9? What times what makes 9?
1 times 9, 3 times 3.
Okay. Are there any others?
No.
Okay. So you have 3 factors for 9.
Yeah.
Let's try to all the factors for 21.
Okay. 1, 21.
1 and 21.
I have to think on it.
Okay.
3.
3 works. 3 times what?
3 times, I'm counting.
Okay.
3, 6, 9, 12, 15,
Mm-hmm.
18,
Mm-hmm.
21.
Good job. Now, how many times was that? 1, 2, 3,
7.
4. Good job. Okay, so 3 times 7. Are there any other factors?
No.
Okay, so we have all 4 factors of 21. So how do we find the greatest common factor?
We have to circle the factors that both match up and which one's higher than the other.
Okay, so they have 1 in common. What else do they have in common?
3.
3. So 3 then is our GCF equals 3.
Yep.
Okay? Is that all your question asked you?
Yes.
Okay.
And we have to divide it, and we have to do 9 divided by 3 and 21 divided by 3, and we have to get the answer.
Okay.
Ah, so you have to simplify
Yeah,
it.
you need to simplify. So we're going to divide this by 3 and the
Yeah.
bottom by 3 as well? Okay. So can you tell me what 9 divided by 3 is?
3,
Good. And what's 21 divided by 3?
7,
Awesome. So your final answer is
3 7.
Very good, Gabriella. Great job with your factors.
That was very good. Greatest common factors.
So what does she get to do
Will you
now?
be my GCF?
I'll be your I'll be your GCF.
Okay.
Your
All
greatest
right.
common friend.
Yeah! Hey, we're going to spin the wheel! I wasn't ready to spin the wheel yet. I was still commoditizing, community-saving. There he goes, Trey! Oh, a water bottle.
Ah.
Oh, I can see him on the beach with their
Oh,
water
that's my
bottles and their
second
sunglasses.
Perfect.
bottle.
Yeah.
You'll be hot in the sun, and then you can quench your thirst.
And the thing about the water bottle, it's magic because it turns blue when you put cold liquid in it. Spectacular. I picked that one out too, by the way.
Did a great job.
All right, you know what? Let's go back out to Norwood and talk to Samantha. Are you there?
Hi.
Hey, Samantha, how are you today?
Good, how are you?
Fantastic. I'm glad you called. We've been waiting for your call, actually. So, what are you working on?
Adding and subtracting decimals.
Oh, hey, we did a little bit of decimals at the beginning of the show. Did you see that?
No.
Well, we're going to do your what's your problem, and we'll do that one too.
Okay. So it's 6 and 24.
Okay.
And plus 1 and 47.
All right. I'm going to help you out a little bit with how to read these numbers. You did a great job by saying and. Our decimal does turn into the word and. but this is 6 and 24 hundredths.
Hundreds. And then it's 1 and 47 hundredths.
Great job, Samantha.
Yeah.
So what do you know about adding decimals?
Oh, I don't like that.
When you get your sum, you always have to line it
Oh.
up with the other decimals.
Yes.
Okay,
Samantha
so
knows
we
that.
did that. We lined up our decimals, and now we're just going to add like we normally would, correct?
Mhm.
Okay, so what's 4 plus 7?
4 plus 7?
Yes.
Oh. The top number, I messed it up. The top number is 6 and 28 hundredths.
Oh, 6 and 28 hundredths?
Yeah.
All right, let's fix that up for you. Up, change the color on you. So it's 6 and 28 hundredths. So now we're going to add 8 plus 7. What's 8 plus 7?
15.
Okay, what do I do with the 1?
Carry it up to the 10th.
Okay, what's 2 plus 4?
6.
And what's 6 plus 1?
7.
All right. And what's 6 plus 1 over here?
7.
Okay. Now I have a decimal. What do I do with the decimal?
You have to put it in the middle of 7 and 7.
Nice job. How would I read this answer, Samantha?
7 and 75 hundredths.
Great job.
That was spectacular. Just the way she was using that vocabulary.
Yes.
Wonderful. Nice job, Samantha. And for that, I'm going to tell you 15 jokes in a row. No!
No.
I'm going to spin the wheel instead. Come on, Trey. Samantha is looking for something special. Oh! The mystery prize.
So what is it? What is it?
Do you want me to tell you what the mystery prize is?
Yes.
I can't! It's a mystery! Do I sound like a diabolical mad scientist?
Yes.
I thought you were a
See that-
beatboxer today.
Oh, I have so many things I want to do. I don't know where to start. But I can tell you, I'm going to talk to TJ first from Newtown, a 5th grader. TJ, are you there?
Yes.
How you doing?
Good.
Are you any good at beatboxing?
No.
What about, can you laugh like a diabolical scientist?
No.
Okay, let's subtract some fractions then. How about that?
Okay.
All right, what's your problem?
3/4 minus 1/5.
Okay, 3/4 minus 1.
Uh-oh, look
Fifth.
at those denominators.
Yeah, tell me about those denominators, TJ.
They're uneven.
Yeah, they're not the same, are they? They're unlike denominators.
Yes.
And before we can add or subtract fractions, what kind of denominators do we have to have?
We have to have even denominators.
That's right, they have to be common denominators. So let's try to get a common denominator for 4ths and 5ths. How do we do that?
First, you find out what number they both have in common.
Okay. So you want to list your multiples of 4?
Yes.
Okay, do that for me. Why don't you count by 4s?
4,
Uh-huh,
8,
uh-huh.
12,
Good.
16,
16, 20, good.
24,
Mm-hmm.
28.
That's probably good. All right, let's try counting by 5s now. Can you do that?
Mm-hmm.
Go ahead.
5,
Mm-hmm.
10,
Mm-hmm.
15,
Uh-huh.
20.
And I'm going to stop there. Do you know why I'm going to stop there?
Because 20 is in both lists.
That's right. So as soon as we get to the one that they have in common, then we can use that to be our LCD. Do you know what that stands for?
Least common multiple.
Close. Least common D. for
Denominator.
Denominator. So that must mean that that denominator should be what number?
20.
Good. How do I find out what those numerators are going to be?
We multiply 3/4 by 5, by 5 to get 15/20.
Okay, to get 15/20. Good job. And how about, what do we have to multiply the 5 and the 1 by?
4 to get
4
4/20.
to get 4/20. Okay, so let's work on our subtracting now. Can we do 15/20 minus 4/20?
Yes.
Sure, what's 15 minus 4?
11,
11. And what denominator are we going to use?
11/20.
Good. So read that answer for me.
11/20.
11/20. Can we simplify that answer?
No, because the numbers are not even.
Right. They don't have 2 as a factor. That's true. And actually, there's only 2 numbers that will make 11 when you multiply. Do you know what 2 numbers make 11 when you multiply?
22.
Well, when you multiply it by 2, but the factors are 1 and 11, right?
Yeah.
So if we can't divide by the same number on either one, then we definitely can't simplify. So 11/20 is your answer.
Okay.
Okay, TJ, good job. You helped me out a lot with that.
Nice job, TJ.
Thank you.
So you can be my GCF, and you can be my LCD. No?
No.
Hey, guess what? We're gonna spin the wheel.
Yay!
TJ's excited. Come on, Trey. From one T to another. Oh, the Magic Math Kit. The Magic Math Kit will be coming to you shortly, guaranteeing all 100% correct math answers. Or there is a money-back guarantee.
Thank you.
You're welcome.
Welcome.
All right, you know what? Let's go to Newtown once again.
Once again.
And talk to Samuel. You there?
Yeah.
Hey, Samuel, can you beatbox for me?
Yeah.
Go ahead, let me hear you.
Oh, that was
not
a
bad.
good
You were waiting for
one.
that,
Hey, now
Adam.
can you be a diabolical scientist?
So,
Okay. How about we add some factors?
Maybe fractions.
yeah.
Okay.
So this is my question.
All right, yeah, what is your question?
7/10 plus 5/10.
Ah, okay.
No, look
We
at
did
those
something like
denominators.
this earlier. 7/10 plus 5/10. What do you notice about this problem?
Both fractions have the same denominator.
They have the same denominator. So what do I do with the numerators?
We did this one, didn't we?
We did.
You just add it.
Let's do
All right.
another
What's
one.
7 plus 5?
12.
Okay. But now look at my answer. What do you notice about my answer?
It's a
Let me do that.
improper fraction.
It's an improper fraction. So what do I do with this 12/10?
You have to make a whole, and there's going to be some left over.
All right, so I'm going to divide the bottom into the top. How many times does 10 go into 12?
Once.
Once. I'm left with 2. What do I do with that 2?
You put it over the 10.
Put it over the 10. Am I done?
No.
No. What do I have to do with this 1 and 2/10?
It's a simplify.
All right. What number goes into 2 and 10?
2.
2. 2 goes into 2 how many times?
Once.
2 goes into 10 how many times?
5 times.
There you go.
That looks vaguely familiar.
Yes, it did.
But it's still worth a prize for you, my beatboxing friend. Come on, Trey. Yes. Excitement aplenty. Oh, another water bottle.
Wow.
And those are those big water bottles.
Just in
you know,
time
big
for the
20
heat that's
those
coming.
24-ounce ones keep you very hydrated when you're on the sports field.
Bye.
All right, thanks for
Bye.
calling. All right, you know what? Let's have a little bit of Faith and talk to Faith. Are you there from Newtown? Hi, Faith.
Hi.
How are you?
Good.
Did you have any cookies today?
No.
Don't they serve cookies in kindergarten anymore? Just not today, huh? So what's your math problem, Faith, and we'll work on it together.
Kevin has 5 apples. He gives one to his little sister. How many does he have left?
So we had 5 apples.
Okay, so Kevin has 5 apples. And then, Faith, what did he do with those apples?
Gave it to his little sister.
How many did he give to his little sister?
2.
He gave, that was
Oh, that
nice,
was nice
wasn't
of
it?
Kevin.
So he gave his little sister 2 apples. Is that right? Do you need to know how many apples he has left over? What's your question say?
2.
Okay, read me again. You said Kevin has 5 apples. Read me the whole thing.
Kevin has 5 apples. He He gives one to his little sister.
Okay, so he gave just one to his little sister, huh?
2.
Oh, he gave 2. Okay, so can you see the screen up here? If he has 5 apples.
5 perfectly round
See?
apples.
See these apples? And then he gives 2 of them to his sister. Here they go. How many does he have left over? Can you count?
3.
Yep, 1, 2, 3. He has 3 apples left over. Faith, how does that sound? Does 3 apples sound good? Okay, great job, Faith.
I'm in the mood for a cookie and an apple. And you know what, Faith? We're going to spin the prize wheel for you. Come on, Trey, get ready. Faith would like a prize. There he is. Trey's cranking it up. And, oh, a flashlight.
Yeah,
I think Faith would like a flashlight, by
I
the
think
way.
so too.
Very good. All right, you know what? Let's go to Paige from Newtown. Paige, are you there? Hello, Paige.
Yes,
How are you?
I'm good.
I'm glad you called today. So, what are you working on in 2nd grade? What's your math problem, and we can work on it together?
We're working on perimeters and areas.
Perimeter.
Oh yeah, we just talked about perimeter. What's your
Perimeter
problem?
and area.
My problem is at the. Hold on.
I think it'll be fast.
I have to see the box, and it's shaped as a rectangle, and there's squares. Hello?
Yes,
Yeah,
we're
listening.
here.
Okay. It's shaped as a. They put lines on it, and I have to count the areas and make lines for the perimeters.
Okay. What type of shape are you working with, Paige? A rectangle, a square, or a triangle?
Triangle. Not a triangle. Rectangle.
A rectangle. All right, real quick,
Yes.
do you have numbers on your rectangle, Paige?
Why don't we make our own numbers up fast?
No.
All right, so we're going to make some numbers up. Let's say I have 1, 2, 3, and 4.
Okay.
To find the perimeter of this, I'm going to add all these numbers.
Okay.
So I would add 1, 2, 3, and 4. I'm sorry. And 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 equals 10.
So that's the perimeter.
So when you do your problem, add them all up, okay, Paige?
And we're going to spin the wheel for you, Paige. The last spin of the day. Ready, Trey? Give it a good one. Yes. I'm excited about that. Oh, and another magic math kit. Outstanding. Well, guess what, Miss Magnuson?
All right, so I think that just about does it for this show.
Can you
And
believe
guess what? There's only one more show left for the season.
Oh, I can't believe it. Oh, well. Congratulations to all of our prize wheel winners. And thanks to our guest spinner, Trey from Glendon Elementary School. He did a wonderful job.
Remember, kids, we do re-air this episode of Math Homework Helpers every day of the week, so be sure to tell everybody to watch. From all of us here at Math Homework Helpers, we'll see you next week.
Yep,
Only here on
BCPS-TV.
BCPS-TV.
See you guys. Last show next week. Believe it.